Welcome to my channel. In the previous lesson, I derived this equation, which is the general formula for solving quadratic equation, from this equation here, which is the general form of quadratic equation. Now, in this lesson, we're going to be looking at this expression under this square root, which is b squared minus 4ac. Now, this is better known as the discriminant, and it tells us many things about quadratic equations. For example, it tells us about the type of the roots of the quadratic equation. It tells us about the nature of the roots. It also tells us about the type of parabola that we'll be expecting at a given equation, and also tells us whether the equation is factorizable or not. Now, in this lesson, we are going to be discussing all of this in details as it regards the discriminants. So let's start. Please, if this is the first time you are watching my video, please feel free to subscribe to my YouTube channel, like and share with your friends. Also, when subscribe, don't forget to turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. In that way, you support me to grow in this platform. So let's start. We have b squared minus 4ac, which is the discriminant, as earlier said. Now, if this discriminant is equal to a perfect square, I'm going to write it as p sq. Now, perfect squares are numbers that can be expressed as the square of an integer. For example, 4 is a perfect square because it can be expressed as 2 square, which is a square of an integer. 9 is a perfect square because it can be expressed as 3 square, which is square of an integer. Another one is 25, which is 5 square. Another one is 36, which is 6 square, and so on. If the discriminant is equal to a perfect square, it means that the equation can be factorized, number 1, and it also implies that the quadratic equation has 2 rational roots. For example, as when you have x squared minus x minus 2 is equal to 0. Let's find the discriminant of this equation and know whether it is equal to a perfect square. Now, a is always the coefficient of x squared, which is 1 in this case. B is equal to -1, which is this coefficient of x, and then c is equal to the constant, which is -2. Now, b squared minus 4 AC, we're going to plug in these values of a, b, c into this expression. So b squared from here is -1, so d is squared, then minus 4. The value for a is 1, and then the value for c is -2. Now, -1 squared is 1, then minus 4 times 1 is 4. 4 times -2 is -8. Then this implies that 1 minus minus is plus. 1 plus 8 is equal to 9. Now, as can be seen, 9 is a perfect square, and then it implies that this quadratic equation can be factorized, and then when factorized, it has 2 rational roots. Now, let's look at another case. Let me wipe the screen. Now, another case we'll be looking at is if this discriminant b squared minus 4ac is equal to 0. Now, if this discriminant is equal to 0, the equation can still be factorized, and it has 1 repeated root. This is 1 repeated root, and then example of this equation is when you have x squared minus 4x plus 4 equal to 0. So let's go ahead and find the discriminant of these quadratic equations. So we have b squared minus 4ac, then our a is equal to 1, the coefficient of x squared, then b is equal to -4, the coefficient of x, and then c is equal to the constant, which is 4. So let's plug in the values of a, b, and c into this expression. So we're going to have b is equal to -4, then square, then -4 into the value of our a is 1, then the value of our c is 4. So you have -4 square is 16, then minus 4 times 1 is 4, 4 times 4 is 16, then 16 minus 16 is equal to 0. So as you can see, the discriminant of this quadratic equation is equal to 0. Hence, it can be factorized. Then it has one repeated root. And then let's look at the final case where b square minus 4ac is less than 0. So the third case is where the discriminant b square minus 4ac is less than 0. So in this case, it cannot be factorized. That is not factorizable. Then you are going to have complex roots. So that's when you start having something like 4 plus or minus 3i, where this 3i is the complex term of the solution. So one thing to know is that if the discriminant b square minus 4ac is greater than or equal to 0, we are going to have real roots. So it can fall under this b square minus 4ac, where it's going to have a repeated roots, or it can fall under this one, where it has 2 rational roots. So let's talk about how discriminant affects the graph of quadratic equation. I'm going to use this side of the screen to illustrate it. So if the discriminant of a given quadratic equation produces a perfect square, we are going to have a graph that looks like this. Now, when it's a perfect square, we are going to get 2 real roots. So assuming these points and these points are the roots of the equation, and then here is the y-intercept, the graph is going to open upwards. Now this is true when the coefficient of x square is positive. Assuming it's negative, that is this a is a negative value, then this graph is going to open downwards like this. Now let's look at the case where the discriminant, which is b square minus 4ac, is equal to 0. Remember, if it is equal to 0, it's going to have a repeated roots. And so repeated roots means that it's going to have only one root. So assuming this is the position of that root, let's say it's 2, then the graph is going to open upwards. So assuming here is the y-intercept, then the graph is going to look like this. Alright, so everything will be on this root, this turning point. This point is called the turning point. It's going to be on this 2. Okay, and so when the coefficient of x square is a negative value, the same thing is applicable. It's going to open downwards like this. Alright, so where this turning point will be on that 2 exactly. And then the final one, when discriminant is less than 0, so we said that if it's less than 0, we're going to get an imaginary root. So imaginary root means that it has no real roots. Alright, so the parabola is going to open upwards for a positive value of coefficient of x square, and then this parabola is not going to touch the x-axis because it did not produce any real roots, so it only produced complex roots. So this is for this video. Please remember to support me by subscribing to my YouTube channel, and that way I'll be motivated to make more videos. Thank you for watching. Have a nice day.